Right, we are beginning actually our discussion looking at the November 2015 IEB Assessment Matters, Mathematics Paper 2, 3 hours, 150 marks. Right, so one thing that is very important about the instructions just to mention is the rounding off. Rule number 8, round off your answers to 1 decimal digit where necessary, unless stated otherwise. So we're using the 1 decimal digit approach when we have decimals. Okay, so you save time, don't write lots of digits, just write 1 because these IB exams are long. 3 hours is too short. Right, so in the diagram below, you have that AB is given, A as the coordinates and B, and M is the midpoint, and AMCO is a cyclic quadrilateral. Wow. AMCO is a cyclic quad. The examiner is telling us with a cyclic quad, there's no circle. What does it mean? It means angle M is how many degrees this? Your thought?
90 degrees as well, sir.
90 degrees. Okay, yeah. Because the opposite angles must be supplementary. So, yeah. Anyhow, the coordinates of M would be very obvious. I'm going to be obviously just teasing you with some of the questions just to make sure that you are on point. But to find the coordinates of M, we shall have x1 plus x2 out of 2. And then we have y1 plus y2 out of 2. Right, so you have x1, y1, you have x2, y2. X1 is 0 plus 12 out of 2. Y1 is 6 plus 0 out of 2. And if you have 12, you get 6. You have 6, you get 3. And these are the coordinates of M, 6 and 3. Write down giving reasons the size of CMA and hence determine the equation of line MC. Right, CMA, giving reasons. You already said that CMA, you've already seen that CMA is 90 degrees. Okay, I'm just passing through some of these. I know they're pretty obvious. Right, so CMA is actually 90 degrees. Why is it 90 degrees? Because you have the opposite angles outside the quad. Opposite angles outside the quad. Right, and then now you want to find the, write down the size of it and hence determine the equation of line MC. The equation of the line MC, you need to first find the gradient of the line AB. So you have 0, 6, 12, 0. You have 0, 6, 12, 0. You have A and B here. So what is the gradient of AB? So the gradient of AB is actually yt minus y1 over x2 minus x1. I know this, you know pretty well. So x1, y1, this is x2, y2. Y2 minus y1 divided by x2 is 12 minus x1. So you divide minus 6 by 12, it becomes what? It becomes exactly minus 1 over, you can just write minus 6 over 12, which is minus 1 out of 2 because 6 goes twice into that. But the gradient of the line AB times the gradient of the line MC must be minus 1. Why? Because AB is actually perpendicular to MC. What is MB? Is minus 1/2. The gradient of MC is minus 1. Because if two lines are perpendicular, then the product of their gradients is minus 1. Then the gradient of the line MC is 2. After we agree that there is MC somewhere here, so M is this, and M has the coordinates we have seen. What are the coordinates of M? Right, the coordinates of M are 6 and 3. So they are exactly 6 and 3. So which means you have y minus y1, x minus x1, right? So you have M 6, 3, x1, y1. So which means it is y minus 3, and the gradient is 2, which is x minus 6. Which means that you have y equals 2 by x is 2x minus 12 plus 3, and this means that you have y equals 2x minus 9. All right, so okay, show that the area of triangle MCB is that one. Okay, so let's look at that. The area of triangle MCB, the area of triangle MCB can be obtained. So to find the area of triangle MCB, you would be interested in knowing exactly what the intercept here on the x-axis is. So we would have MCB. Right, so obviously looking at like MCB, so M has the coordinates 6 and 3. Okay, we've already got the equation of the line MC. Is this one? So you have y equals 2x minus that, which means now we want to find the x intercept. Right, for the x-intercept, you let y be 0. If y is 0, then you have 0 equals 2x minus 9, which means x is 9 out of 2. Okay, so we're getting the x-intercept, and then after we go to the x-intercept, it means we know the coordinates of the point C. C would have the coordinates x is 9 over 2, y is 0. Okay, once we get this here, we shall have a chance to know exactly what the length is, because the coordinates here are 9 over 2 and 0. Okay, what is the distance from here to there? You can find the distance by subtracting 12 and that, but what is the height? So the height is the y value, which is 3 there. Right, so which means therefore, what do we have here? So what is CB? CB, the distance between C and B, you can easily get because y is 0, so you can just substitute, rather subtract the x components, 12 and 9 over 2. And then you have 2 by 12, which is 24 minus 9 over 2. What is 24 minus 9? It is 15 out of 2. And 15 out of 2 is like 7,5. So we have already got that, the base, right? So what is the area? Area of triangle MCB, half base by height. What is the base? CB, 7,5. What is the height? The height is exactly 3. Right, so we get exactly this. Okay, what do they want here? We're finding the area of MCB, which is this one. Yeah, good. So that is the area of MCB. And then you can be able to use a calculator. What is the answer to this? Okay, need to just use a calculator quickly. Half times 7,5 times 3. So this is actually 11,25. Right, so it is square units. So that is the answer. What about now the area of triangle, or of the area of AMCO? Let me see. AMCO. AMCO. Right, so let's see. We have this. You have this here. And here you have this one. You have M, you have C, you have O, you have A, and then you have B. You've already got this area, so we're interested in this one. So area area of AM, the area of AMCO is the area of the big triangle, so you can take the area of triangle ABO minus the area of triangle, this one MCB. What about the area of triangle ABO? Right, so it is like the coordinates would be at 12, so which means you have 12 here, and then the height would be the value, the coordinates of A. What is the Y value at A? The Y coordinated at A. So did you have anything? Yeah, okay. 0 and 6. 0 and 6. So the coordinates here of A are exactly 0 and 6. So that the area of triangle ABO is half the base is 12. Okay, you don't need a lot of formulas in the exam, please. You need substitution. That's very important. So if you can be able to avoid sometimes writing a formula to save time, you can just say half the base 12 times the height. So it's base by height, and the base is 12 and the height is 6, the Y value there. Minus now the area of triangle MCB. So MCB is this one, 11,25. So you subtract this one. So this is like 6 by 6. So this is 36 minus 6 by 6 is 36 minus 11,25. And the answer is 24,75 units squared. So this is the area of AMCO. All right. So that is what we get there. Next. Right, look at question 2 quickly without wasting time. In the diagram below, circle center N is drawn. The equation of OD is that one. Okay, let's just check. The equation of OD is 7y equals 10x. The equation of ON is y equals x. The equation of EF is y equals a half x plus 4. OABC is a square. OABC is a square that touches the circle at 4 points. So obviously now this OABC is a square. It means all the sides are equal to each other. Right. Okay. OABC is a square that touches the circle at 4 points on the circumference. Right. Show that N is 8, 8. How do you show that N is 8, 8? It's too obvious. Your thoughts quickly? Right, so you're going to put these two equations. There are two equations that intersect at the point. So
it's going to make them simultaneous equations.
Simultaneous equations. I agree with you. So you're going to have this one is going to actually intersect with that. So you have half x plus 4 equals x. Okay, the x and the half x plus 4 intersect, so you can just equate them. Please do not waste a lot of time on these questions, and therefore be in a position to multiply through by the fraction. So multiply through by 2, and you have x plus 8 equals 2x, and this is exactly 2x minus x, which is x equals 8. When x equals 8, what is, use the other equation, which is y equals x, and x is 8. What are the coordinates of the point N? The coordinates of the point N are exactly 8 and 8. Write down the coordinates of the point B. Right, so now we need to find the coordinates of the point B. Right, obviously you have already found the coordinates of this point. They are 8 and 8. We can use these to find the coordinates of the point B by really saying, what is the radius of this? What is the radius of this circle? Anything? Right, so what would you do to do this? So you would say x is 8 and also y is 8 here. And this is like the radius, because distance from the center to circumference. So this is going to be also 8 units, so it's going to be 16, 0. This is also going to be 0, 16. So this is going to be 16, 16. So what are the coordinates of B? We've already seen that the coordinates of B, you need to write down, no explanation, 16, 16. Next. Determine the length of DB. Let's check DB. DB, right. So to find the length of DB, what would we do there? Right, there are a couple of things we need to realize. Right, it is to say, what are the coordinates x at D? So here you would have x at D and y at D, but you already know that y is 16. So which means this one is 16. You just need to get x. But to get x, you can use this equation. So you're going to take the equation 7y equals 10x. So you take the equation 7y equals 10x. Right, and this 7y equals 10x, we already know that y is 16, which is 10x. And therefore, xd is 7 by 16 divided by 10, which is the same as, if you use a calculator, 11,2. And therefore, what are the coordinates of D? We've already seen, therefore, that the coordinates of D are 11, 2 together with the y value, which is exactly 16 there. So we have got the coordinates of D, right? So when we got the coordinates of D, so this is one is like 11, 2, okay? Then now we answer the question, what is the length of DB? So to find the length of DB right now, we need to find the distance from here to there. So we get the y values are the same, so just subtract the axis. So the x values. So it's 16 minus 11, 2. So, and it's exactly DB. DB, which is 16 minus 11, 2, which is 11,8 units. Okay, we're back in trig now. Right, let's look at trig. Now I'm going to spend a bit of time on trig a little bit. Okay, so let's look at these now. So I'm going to involve you a lot here. Obviously, we have two kinds of angles. I'm going to draw the cast diagram real quickly. And this is 0 degrees, 90 degrees. Please, I need your maximum cooperation on this one, just to make sure you get a little bit of the trig remembered, so that you can remember a little bit of the trig. Okay, when you get to this point, in this quadrant here, you have 90 degrees plus theta, because you're going this way towards 180, but also you have, say, 180 degrees minus theta if you go back. So 180 degrees plus theta, 270 degrees minus theta. So 270 degrees plus theta, 360 degrees minus theta, 360 degrees plus theta, 90 degrees minus theta. Okay, this is sort of the calculation I'm going to have. So let's look at this question. Two things remain very important for us to consider. The sine of minus theta is minus the sine of theta. And when we have the cosine of minus theta is actually cosine theta. So now what we get out of these, in each quadrant is 180 minus theta. What do you think?
So it's sine.
Yes, it's sine theta, right? So which is quadrant 2, so it's going to be the sine of theta because it's in quadrant 2 and the sine is positive. Okay, what about cosine 90 degrees minus theta?
So I think that's sine theta as well.
Sine theta as well, thank you. Minus 1, and it is divided by, what about cosine of minus theta?
It's cos theta.
Cosine theta, well done, thank you. So this is sine squared theta minus 1, it is divided by cosine theta. What is sine squared theta minus 1? Can it be simplified?
Cos squared theta.
Because yours is close to that. It's a small little trick. Because sine squared plus cosine squared theta is 1. So cosine squared theta is 1 minus sine squared. So this one is sine squared minus 1 is not 1 minus. So you need to pull out a minus so that it becomes 1 minus sine squared divided by cosine theta. What is 1 minus sine squared? Now, 1 minus squared is what it is cosine. So it's minus cosine squared theta of a cosine theta, which is therefore minus cosine theta. And it is the answer. It's exactly the answer. So the answer is actually minus cosine theta to this question. Obviously, you have to keep this Chaos diagram at the back of your mind as you move to the next question. Okay, I'll need maximum cooperation from you as well on this question here. Determine the value of values of the following. Yeah, determine for which values of these of theta between 0 and 360. Will this square root be real? So what do we do here? What do you think we do here? What's the answer to this? Where will this be real? What do we do? Where do we start?
So I think we're gonna square root the answer that we got in question 1. And then I'm not gonna...
Okay, and what answer did you get in question 1?
So we got negative cos theta.
We got negative cosine theta. So we're going to write it like this and say minus cosine theta. That's correct. Minus cosine theta. So now, if it's minus cosine theta, when will this be real? So it's going to be real when minus cosine theta itself is bigger than 0. We need these to be bigger than 0 or equal to 0. Okay, determine the values for which these should be. So it must be greater or equal to 0. Or, right. So strictly speaking, you can say, let's not allow it to be equal to 0. Just make it strictly bigger. Or you can say cosine theta is less than 0, negative. Okay, because we take the square roots of positive numbers. Positive numbers, so whatever is under square root must be bigger than 0. So in which case, therefore, you shall have that. So when is the cosine theta? Okay, if what is under square root is bigger than 0, okay, because we have the cosine in the denominator, ordinarily we take 0, we take the square root of 0 and numbers larger, but because the cosine is in the denominator, we can't allow it to be 0, so I'm just saying it's strictly bigger than 0. Meaning also, this is the same as this, because if you have this minus cosine theta is bigger than 0, you can divide by minus 1 both sides. So that it becomes this. And then the inequality sort of changes direction because we divided by negative. It was greater, now it's becoming less. Okay. Let's solve for x here. What are the values of x here? Or values of theta? Values of theta. All right, so you need to think about it to say when cosine is less than 0, when is it? Okay, you need to just look at the cosine graph very quickly. And then cosine 0 is 1. At 90 degrees, it is 0. $180, $270, so that you have that 360. Obviously, we're looking at things between 0 and 360, so this is sort of the graph. So when cosine theta is less than 0, we're looking at where cosine theta is negative on this graph. Where is it negative? Cosine theta is negative between 90 and 270. So which means that theta is an element of the interval from 90 degrees to 270 degrees. That's where the function theta, the cosine theta is negative there. So we're done with that question. Or you can use other methods like your reference angle. You can consider an equation, arc cosine 0 is 90, and so on. You can use your calculator.
Sir?
Yes, please.
So why did we leave out the square root?
That's a good question. Why did you leave out the square root? Okay, we left out the square root because we wanted to look for where it's real. So where it's real, we actually, if you have x, determine the values of x for which this whole thing is real. So when the whole thing is real, it depends on what is under the square root. So it is real when what is under the square root is bigger or equal to 0 in mathematics. Because you can take the square root of 4 is 2. The square root of 16 is 4. So we just have to take what is under the square root, because for this whole thing, for which this whole thing, the values of or the values of theta between 0 and 360, for which this whole thing is will be real. It is real only if we consider under what is under the square root, and what is under the square root is positive. Okay, so obviously then we leave out the square root there because it's just there to say, to give us the real, to tell us why it's real. Because if you have the square root of -4, what is the square root of -4? Okay, the square root of -4 in university mathematics is 2i, but in the school curriculum, in particular in this course of mathematics, we say it is non-real, provided you do technical math. In technical math, we know it is 2i, but it is non-real. Why is the square root of -4 non-real? Why is the square root of 4 real? The square root of 4 is non-real because the square root of -4 is non-real because the number under the square root is a negative number. So if we want the result to be real, we must make sure that what is under the square root is a positive number. Then we're going to have a real answer. So an answer that's a real number. So here, this is the square root of minus cosine theta, but we want this whole thing to be real. So, but this whole thing is simplified to this. We want this whole thing to be real. So we must just have minus cosine theta being bigger than 0. If minus cosine theta is bigger than 0, if minus cosine theta is bigger than 0, then we have the square root of that is real. Examples of that would be, okay, we say the answer is theta between 90 and 270, excluding the extremes because it is 0 at 90 and 270. So we put round parentheses here. Okay, let's take theta to be any value that's between these things here. Like between 90 and 180, you can, between 90 and 270, you can take like 180. Okay, and you put it here. You want to check if these, what these answers mean. So if you check, you take everything. The square root of 180 degrees. Okay, 180 is just a number, a number of degrees that is between 90 and 270. Or that number is between 90 and 270. So what is cosine 180? Is -1. And the square root of 1 is what? It's a real number, is 1. So indeed, it means that if you take any number of degrees that is between 90 and 270, you will get that the square root of these is producing a real number. What about if somebody's going to say any theta that's outside these, like 0 degrees? You take like cosine 0. Cosine 0 is 1, and the square root of -1 is non-real. So we found the values of theta such that the square root of everything with the square root is real. So yeah, if you want to find, if they ask this question about real things in the exam and they put a square root, you forget about the square root and take what is under and check what is under the square root. Okay, next question. Right, prove the following identity. I'll need just your maximum attention here. The doing trick is a little bit of interest. There's not a lot of trick. That's why to do other questions, I'd have to be switching from one paper exam to another. So to do this one here, you need to take to prove this, you let the left-hand side. Right, so you take the left-hand side. Which is 10 theta sine theta plus cosine theta. What is the tangent of theta? It is the sine of theta over the cosine of theta times the sine of theta plus the cosine of theta. What is sine times sine? It is sine squared theta divided by cosine theta over 1. The LCD is cosine theta. Cosine theta divided by cosine theta is 1. Sine squared theta plus cosine theta divided by 1 is cosine theta times that, which is cosine squared theta. Cosine times that is 1 over cosine theta. Right, so this 1 over cosine theta is the answer. So prove the following identity, and the 1 over cosine theta is actually equal to the right-hand side. So the left is equal to the right-hand side there. So way too easy. Next, we have to determine the general solution to this. The general solution to this now is what exactly? Okay, these guys like linking questions. Okay, we already know that the left-hand side here is 1 over cosine theta from the previous question. And this is actually 3 over sine theta. Right, so we have this and we cross multiply this, which is exactly sine theta, which is 3 times cosine theta. Right, you divide both left and right divide by cosine, it becomes the 10 theta, which is sine over cosine. Right, and this here, it is equal to the number 3. Right, from this, we're able to get the reference angle. What is the reference angle? It is arctan. Arctan of 3. What is arctan of 3? It's 71,57 degrees. And therefore, what is theta equal to? Right, so the couple of things to consider here when the tangent itself is positive. So you can look at the cast diagram. So you have that the tangent here is positive there, but also the tangent is also positive there as well. And therefore, we're able to see that at this point, our theta is actually 71,57 degrees plus k times 180 degrees times k as an element of z. So also you have obviously those two angles, but the next angle is going to be either here or there. So this one here is the angle that is actually 71,57 degrees, but there's another angle that is like so. Okay, so the angle that is like so is this 71 is actually called this. This is like a straight line, so that this is 180 plus that. So it's 180 plus 71,57 degrees. So 71,57 degrees This is 180 plus. So when K is 1, this takes care of that, of the 180 plus part. So yeah, this is no need. So therefore the answer is theta equals 71.57. It takes care of this, but when K is 1, because K is an element of the set of integers, we have also the 71 plus 180. We solved it. Next question. Right, question 4 in the diagram below, you have a couple of points. A, B, C, and D lie on the circle. A, B, C, and D lie on the circle. A tangent is drawn at point D with a chord drawn from A to C. Prove that C2 equals D3. Prove that C2 plus, okay, yeah, anyway. Prove that C2 plus D3 equals B. Right, so you have a tangent. A tangent is drawn at point D, so you'd have the angle technical theorem. So if this is the case here, so you have this here equals this here. You have this equals exactly that. Okay, if it's a tangent, then you have that this angle equals this. Okay, prove that. Okay, so yeah, D is with a chord D, that is a tangent is drawn at point D with a chord D drawn from A to C. Prove that C2 plus D3 is B. C2 plus D3, C2 plus D3, C2, yeah, prove that C2 plus D3 is actually B. What do you think? Need to give you a chance to think. Where do we start?
So can I just see the points that they gave us at the top as well?
Okay. All right. We're going to do it obviously together now. But now what do we do first? What is the first step? We need to prove that C2 plus D3 is B. Okay, one starting point can be we need to add two angles. Our answer must add two angles. But when you add the two angles, we must actually involve the angle B. So the starting point would be to add, to use angle B, and it's actually sitting there. It's sitting at a very awkward position. But in terms of a cyclic quad with 4 vertices, we can add B and D2. So B plus D2 is 180 degrees. So angle B plus angle D2 equals 180 degrees. Why? Because they're opposite angles of a cyclic quad. Please think about the next step. Opposite angles of cyclic quad. Opposite angles of cyclic quad. B plus D2 equals 180 degrees. Right, next. What is the next step? We want to involve D3 now. How do we involve D3? Because now we have these things here. There's D2 here, but we must involve D3. And we must involve D3 and B and C2. So to involve D3 now, we can just look at these and see that D1 plus D2 plus D3 is equal to 180 degrees. Angles on straight line. Okay, D1, D2, the tangent is a straight line, so you can add all the three angles and must get up to 180 degrees. Next, now we know that also angle D1, we've already said it is equal to the angle D2. So, but but it is clear that angle D1, so if you look at angle D1, it must be the same as C2 because of the ten-chord theorem. So D1 is equal to angle C2. Why? Because of the ten-chord theorem. Ten-chord theorem. Hence, what is the conclusion right now at this point? Obvious. This one is 180 and this one is 180. So we're good. We are good. Because so in other words, it means that we can start by saying angle D1 plus angle D2 plus angle D3. Okay, if add all three is 180, but it is equal to angle B plus angle D2. But D1 is C2. So in other words, what do we have? D2 cancels out, and we have angle D1 plus angle D2 is equals to angle B. Obviously at this point, what is angle D1? It is C2, so in the place of D1, you can put C2, which is D2 equals angle B. This is true because angle D1 is equal to angle C2. This is true because angle D1 is equal to angle C2. This is true because angle D1 is equal to angle C2. Next question. So we're supposed to prove that C2 plus D3 equals B, and we've proven that. Okay, use the diagram below to prove the theorem that states that the line drawn from the center of a circle and perpendicular to the chord bisects the chord. A line drawn from the center of the circle to, and that is perpendicular, drawn from the center of a circle and perpendicular to the chord bisects the chord. We need to prove that it bisects the chord. So we have that. So let's do a construction. Right, so you'd have to join. You'd have to join like so. Like so. So you have to join AO and OC. What are we required to prove? We are required to prove that it bisects the chord. So bisection is about actually proving that angle AM is equal to angle MC. So let's look at the proof of this. So which means that in triangle, so we're going to be based in triangles OAM and the triangle OCM. So we can see that OM is a common side. OM is a common side of these two triangles. They're both joined by the side OM. But also, next point, we have OA is equal to OC. These are radii. So you have that M1 is equal to M2. M1 is equal to M2, which is 90 degrees. Why is M1 equal to M2 equals 90 degrees? This was just given that way. And therefore, it follows that the triangle AOM is actually congruent to triangle COM. Congruent to triangle COM. Why is this the case? Because of the right angle, hypotenuse, and side. Right angle, hypotenuse, and a side. Because of these, we can therefore say hence. Right, hence AM is equal to MC. Hence AM is equal to MC. Hence AM is equal to MC. Right, we're supposed to just prove by section that the line drawn from the center of a circle and perpendicular to the chord bisects the chord. We're supposed to prove that this is the midpoint, so that M bisects the chord, or OM bisects the chord AC, and it follows that we have proven that AM is equal to MC. And with our next question. Right, in the diagram below, O is the center of two concentric circles. So we have that O is the center of the two concentric circles. A is the diameter of the larger circle and is 20 units long. Right, so we have that A is the diameter of the larger circle, and we can see that it is actually given some length, and so it is 20 units long. So this here is 20 units long. Let me do this before I forget. It is actually 20 units long. Right, GF is the diameter of the smaller circle and is 8 units long. So you have that GF is the diameter of this circle and is 8 units long. Is 8 units long. Chord AB has a length of 12. Chord AB has a length of 12. Okay, I'm just putting these things so that we would not forget, because they might ask us some questions. If they give me some values, please always put them in the diagram, just in case they ask, so that you don't get stuck because you just missed some information. OD is perpendicular to BE. So OD is perpendicular to BE, okay? It's making an angle of 90 degrees. OC is parallel to GB. OC is parallel to GB. Is parallel to GB. Okay. What is the question? Determine, giving reasons, the length of BE. Okay. Determine, giving reasons, the length of BE. Your take on this question? What do you think the length of BE is? Maybe you already know. Right, first things first, we know that the angles are tended by a diameter. This one's a diameter. It obtains an angle of 90 degrees of circumference. The first thing we write down is that we can see that we have right angle triangle, because we can use Pythagoras theorem somewhere. We're given lots of lengths and triangles, so Pythagoras theorem becomes, so B is 90 degrees. You know, this is true because we have an angle in semicircle. So you have BE. Right, so if we want to find now BE, it's obvious, because if this triangle is right angled, so you have the triangle like this. So you have this here. Okay, A here. This is A and this is E. This is 12 and this is 20. And we just need to find BE, and this angle is 90 degrees. So we can use Pythagoras theorem and say that the B is squared. B is squared, because now we want B is squared. But the hypotenuse is this one, so it is equal to the hypotenuse squared minus the other side squared, which means that this one. Why are we putting the squares here? It is a theorem called the Pythagoras theorem, and therefore we proceed like this, and to be able to see that BE squared is the square root of 20 squared minus 12 squared, square root here. This means BE is the square root of that, which is exactly 16 units. Which is 16 units. Okay, so we have that. Right, next question. Determine giving reasons BC over CE. BC over CE. Okay, let's look and see that we have BC over CE. BC over CE is equal to what? Right, we can see that BC over CE is equal to GO over OE is equal to GO over OE. So in other words, BC over CE is equal to GO over CE. And what is GO over CE? GO over C. Let's check what is GO. Right, obviously here we're dealing with the fact that this one is the diameter of the smaller circle, 8 units, so 8.5, half is the radius here, and obviously you also have that now, so you have GO, but you need OE, right? So you already know actually the OE, because this length here is, the diameter is 20, so that the radius here, the distance here is actually 10 units, and therefore it is OE, which is 4 over 10, which is 4 over 10, which is exactly 4 out of 10. Right, and now if it is 4 out of 10, or you can say it is 2 out of 5, why is this the case? Because the theorem says that the line parallel to one side of triangle, line parallel to one side of triangle, or do you want to say that? You can say it is the mean proportion theorem. Mean proportion theorem is called the mean proportion theorem. So you have that. So yeah, the BC over CE is 2 out of 5. Next question. Hence or otherwise determine giving reasons the length of CD. The length of CD. Let's find the length of CD. What is the length of CD over there? Right. So the couple of ways, obviously, that you to consider to find the length of CD, you can easily be able to find the length of BD. What is the length of BD? Right. So at this point, we can be in a position to determine that, right? Because if you look at that, at the fact that the length of the distance from the point B to the point D, you can actually be in a position to easily, but very easily determine that part there. Right, so there is a line from the center that is perpendicular to the chord. And now, according to that theorem, if there is a line from the center that is perpendicular to a chord, it is such that it must bisect the chord. Must bisect the chord. We've just proven the theorem there. So which means that at this point, we can actually be in a position to say, because we found the whole of BE, what was BE? BE was exactly 16. BE was exactly 16. I do found it here, just down, passing it, just went past. Right, here it's BE 16, so we need now BD. BD. So if BE from here to there, it's 16. Okay, this is a line from the center that is perpendicular to a chord. It must bisect the chord, making these 8 units and making that 8 units. So, which means therefore, with 8 and 8, with 8 and 8. So if you have 8 and 8, what do we get? Right, so we have exactly that BD is 8 units. I want to find that one. So we write that one down, that BD is actually 8 units. Okay, if BD is 8 units, then we can be able to find BC over 16. BC, now we can be able to use ratios here. We can be able to use ratios over here. So we can be able to see that BC over 16 is equal to, is exactly equal to 4 over 14. So that is BC over BE. Can write that one down. BC over BE. Right, so we can say BC over BE is equal to, for example, GO over GE is equal to GO over, is it GO this? Yeah, is it GO over GE over GE? Just so that in the end, we have therefore that this is true because of the fact that of the proportionality theorem and the fact that we have that this line here, CO, is parallel to the line BG. So CO parallel to BG given. CO parallel to BG given. So which means that you have BC over 16. GO is 4 over 14. So which means you have BC, which is 4 over 14 times 16, which is 4,57 units. 4,57 units. BC is 4,57 units. Right, so you'd have therefore that BC here is 4,57 units. And we now want to find CD, but you already know this is 8. So in other words, CD is going to become 8 minus CD is 8 minus 4,57. All right, would come and say therefore CD is 8 minus 4,57 units, which is 3,43 units. Like so. And now, after this question said that hence or otherwise determine given reasons the length of CD, so the length of CD is 3,43 units. Next question. Right, if you look at the question 6 in the circle below, draw any two chords, not diameters, right, A, B, and C, D, intersecting at point E, a point inside the circle. Okay, that is the first question. So let's draw together. So what we're going to do? There's a B, a B, and this one is like so. Okay. I will remove this. I'm going to cut this. I'm going to cut this. And I'm going to cut this. And I'm going to keep my pen here. And I'm going to go back and go to full screen. Okay. In the diagram below, draw any two chords A, B, and C, D. Let's just draw the chords first. A, B. Like this. Okay, so in the circle below, draw any two chords, not diameters A, B, and C, D, intersecting at point E, a point inside the circle. So they intersected point E, a point that is inside the circle, 1 mark. Right, next we need to prove that triangle AEC is similar to triangle DEB. Right, so AEC and this one here. So we have that angle A must be equal to angle D. Angles in same segment. But if you have A equals C angles in the same segment, but also you have that C equals B. Angles in same segment. So that's now you have that this angle equals this and this angle equals this, but also you can take the third angle. You can take the third angle, so you can take angle AEC. So angle AEC is equal to, so angle AEC is equal to angle DEB. Like so. Okay, these angles are equal because they are vertically opposite angles. Right, so what we have here is that these here are three angles are equal in their respective triangles. Sort of the corresponding angles are equal. And therefore, we have that triangle AEC is similar to triangle D, EB, angle. So yeah, we've proven therefore that these triangles AEC and DEB are similar triangles, as we have shown in the here in this particular solution. Next point, prove that this is the case since a triangle, okay, we've proven that triangle AEC is similar to triangle DEB. It has been proved in B above. It has been proved in B above. Okay, from this, we have that this is the first two, AE over DE, EC over EB, AC over DB. So you have AE over DE, AE over DE. Yeah. So we're going to take AE because there's AE that appears. So we're going to take the AE part, but we also have the ED or DE, it is the bottom here, but we also have EB and CE. So we're going to take the first and that. So normally I write everything so that we have AE over DE, which is EC over EB. So, which means therefore that AE multiplied by EB is equal to EC times DE. Cross multiplication produces this. But if multiplication produces this, then we have that AE times EB is equal to DE times EC. Next question. Right, if you look at this one here, okay, we did this one, but let's just practice together. Again, I did this example, but it will be very useful for us to practice together. So we're going to do regression analysis. Right, in this question 7, start the table below and answer the questions that follow. Calculate the line of best fit, comment, and so on. But now I decided here I'm going to use the calculator. Yes, please. Yes, please. Okay. Yeah, you're talking to me, Mara?
Yes, sir. Can we do a different question on statistics where they ask us to like draw the, I think, line of best fit on a graph?
Oh, okay. All right. That's fine. We shall do that as well. Okay, I'm going to actually organize a question where you need to draw the line of best fit on a graph. Okay, so that we can discuss how the line of best fit is drawn. Okay, yeah, that's all right. That's okay. But my wish has been also to include these questions in within this video. So I would just include them very quickly so that you press 2. And then so that this video, I wanted this video to sort of be complete. 2.1 for X, and then the next X is 4.2. All right, I'm going to run really fast on this because I want just this to be incorporated here. You have 5. I know that you're very aware of this. 6.8. Right, and then you after 6.8, it's 9. After 6.8, it's 9. And then the next thing is just incorporate the y values. Right, so right, y starts at 3.2, and then 6.4, and then 14.8, and then 18, and then 25.2, and then like 34. Yes. Okay, obviously when you just calculate the line of best fit, so we can press on. Right, shift stat, shift 1. We are doing regression analysis, so we are doing shift 5. Right, obviously about finding the values of A and B, so we can find first the value of A, which is the number 1. And we can see clearly that the value of A is a -2. So as I said, we're going to run really fast on this. We're not going to waste a lot of the time here. So we did this. Right, so A is -2 and B equals, right, the calculator is still there. So we're going to go on, and then we're going to shift set. Then we're going to do regression 5, and then we're going to do 2 for B, and then B equals 4. Right, so what is the equation of the line of best fit? So, right, we have got that. So let's go full screen for now. Right, which means therefore at this point, we know that the equation of the line of best fit is y equals a plus bx, and which means therefore it is y equals, what is the a? The a is -2 plus 4x. You can also write your answer is 4x minus 2. We did this last time. No surprises there. Comment on your answer. I'll just comment very quickly. Okay. Comment on your answer by first calculating the correlation coefficient. Right. So I'm going to quickly do the correlation coefficient. The calculator is still there. It has the data. Did not delete anything. So that it's going to be shift stat. Then we're going to do regression analysis. Then the correlation coefficient is number 3R. And we get the number 1, so which means the correlation coefficient is 1 there. Okay, so we have seen that. Right, so first things first, we can see the correlation coefficient is 1. We're going to do that question, please. I'm going to bring it. Then we have a perfect correlation. All right, so continue quickly. Perfect correlation, because obviously we're to comment on the answer, but we're getting 1 is a perfect correlation, because normally it's like 0.9 something, 0.8, but like it's perfect, so because it's 1. Right, the scatter plot below is a graphical representation of the relationship between a household's monthly electricity bill and their monthly water bill within the same suburb. Electricity bills between 100 and 1,000 were used in the study. So you have that, label the outlier in the diagram and call it T. Okay, we're going to quickly go through this because I know we went through this. Right, so we've labeled it the outlier. There are no other quite clear outliers there. Next, comment on the relationship between the household's monthly electricity bill and monthly water bill. Right, so what do we see here? The relationship between the water and the electricity bills there, okay? There's strong positive relationship because they are closer, most of the points are closer to each other. So you have a strong or positive relationship, or you can say, if you don't want to say that, you can say as the water bill increases, so does the electricity bill. electricity bill, okay. Right, if the outlier was removed from the data above, how would this affect the correlation coefficient? We saw that the correlation coefficient would most certainly increase. The outlier is what would potentially weaken it. So removing an outlier, it would increase in magnitude. So the correlation coefficient would most certainly increase. The equation of the line of best fit is A plus BX, including the outlier. If the outlier was excluded, what would happen to the value of B, right? If the outlier was removed, the value of B would increase because it is certainly weakened by the outlier that is deviating from the rest of the data, making the correlation weak. And we want it to be a strong positive correlation. Right, so we have 5. If a household has a monthly electricity bill of 3,000, can you estimate the amount that will appear on the water bill for the month by using the above equation? Right, so we saw that obviously an electricity bill of 3,000 is outside the range we discussed out last time, just recapping on that, because the electricity bills between 100 and 1,000 were used in the study, between 100 and 1,000. So here they're mentioning 3,000, so we can see 3,000 is outside. So we would say most certainly no, as you would be extrapolating. So it is extrapolation. We started things from 100 rand to 1,000 rand. It's called extrapolation when we now want to study things outside. So as you would be extrapolating, you'd be wanting to sort of extend the graph beyond what the limit is 1,000. So this 3,000 is outside, or the equation is valid. The equation is valid for values of x, between 100 and 1,000. Okay. Or yes, but the result will be inaccurate. The result will be inaccurate because that equation of best fit, the graph is for 100 rand to 1,000, so 3,000 is outside, so any extrapolation will be inaccurate. Right, obviously we looked at this very quickly. We shall just recap on this. The diagram below is an OGIV for the mark distribution of a certain grade, and right on the same grid as the OGIV sketch, the histogram for the mark distribution of the grade. So I'm going to try to use a slightly detailed approach on this. All right, to do this, you can actually use this table here and use the class intervals. Right, so if you put your class intervals here, right, you do your class intervals. And then what are they? So you would start and organize the things like, you can see that the things are actually 0 up to certainly 20. So, right, so if you start at 20 to 30, 30 to 40, right, so you include this, okay, so this is out. So you have 40 to 50. And then here you have 50 to 60. And then you have 60 to 70, 70 to 80. 80 to 90. 90, just 90 to 100. So you'd have something like this. And then you would have the frequencies. And then you'd have, you can put some horizontal divisions just to make sure the data does not get mixed up. Values can get mixed up. The frequency. Okay, so between 20 and 30, what do we have between 20 and 30? Okay, we analyze that. Like, if you analyze very carefully, up to 30, we have 2 units. So the frequency is 2. And the cumulative frequency is also 2. But that would be a 2, and then you do this, drawing the histogram from the frequency, from the octave, cumulative frequency curve, this one. Okay, next. We consider between up to 40, for the second one up to 40. Right, by how much did it increase then? Because up to 40 is at 246. 40 is at 6. So in other words, the next frequency became like 4. So that this is 6. So it is 4. So it's like 2, 4, because this is like 2, 4, 6, 8, 10. 4 here at 40. And then it is 4 up to there, like this. Just 4. All right. And then now at 50, it is 10. If at 50 it's 10, by how much did it increase by if the cumulative frequency is 10? So it must have increased by what? Because this is 2, 4, this is exactly 4. Two, 4. Approximately. Okay. So we have that one. Next, we did this. Okay, so I'm just cruising quickly. I just want this to be part of the discussion and the recording. So up to like 40, 50. Then you have like 50, 60. At 60, what is it? At 60 now, yeah, we saw that at 60, it's between, okay, it's 10, 12, 14, 16, it's like 15. So if this one is approximately 15, by how much this one increased by? Because this is 16, so this increased by like 5. So which means that this is going to be like at 5, 2, 4, slightly above. There's always sympathy for the inaccurate graphing. My pen is thick, yeah. Okay. But yeah, it's 5, so 5 would sort of be between, is sort of in the range there. Okay, so that's something you need to know. Hello, my dear. Oh, is it? All right. Okay, we'll sort that out, my dear. Okay, thanks, my dear. Right, you have this. So, right, so if you have 20 to 80, right, 60 to 70, yes. Yeah, 60 to 70 now. At 70, what is it? So 70 is 20, 22, 24, like 25. Okay, so the cumulative frequency is sitting at like 25. So it means there was a jump by what? By like 10. Because if you add these, it's 6, 10, 15, 25. The original frequency was 10. So if the original frequency was 10, it means that between 60 and 70, you have 10. You are here. You are here at 10. Next. At 80, strictly x less than 80. Okay, so obviously agree that these things here are like potentially like this, just like that. So we have this. Between 70 and 80. What is it? Okay, 80. It's 40. 40 here. So it's 42. It's just about 44. So if this one is approximately 44, 2, 4. It's about 44. Right, if this one is 44, by how much did it increase? Cumulative frequency is 44. This one here is sitting at, by how much did it increase by here? Which means that between 80, we're at 25 here. So if it was at 25 cumulative, this one must have increased by approximately like what? Okay, just 1 second. We're gonna establish that one. Right, that is 70 to 80. About 19. About 19. If you add 19 plus that, so you have 25 together with 19. So which means 70 to 80, you are at 19. You have that. Okay, next we're finishing quickly, please. Between the next one would be between what and what here? Would be between what and what? So between 80 and 90, 80 and 90, we are where? Between 80 and 90, okay, let's look 90. 90 is here. 90 corresponds with 100, but it goes 102, 104. That is about 104. Cumulative is about 104. 24. It's about 100 and how about 104, 103? About 104, 103 approximately. Okay, these are approximate values. You are allowed to approximate because these are not very accurate. So now 103 would mean a jump by how much here? So if it's 104, it would have increased by 60. It was 44 and then 104, it increased by 60. So which means that we're going to increase this one by like 60. So which means we should go 60. Right, so now the 60 is going to be like 60. like so. All right, and then next, between 90 and 100, between 90 and 100, as said already, this is like 90, 100. So obviously, at that point, you have 90 to 100. All right, between 90 to 100, let's check at 100. 100 is sitting at exactly 140 cumulative. So by how much did it increase? It increased by like 36. It's 104 plus 36, so which means that we must check 36. For 6, just a little bit. So this is 30 to 4. This is 30 to 4, 6. Like this. Okay, we get this. So this is sort of be the graph, the histogram. Okay, sort of the idea. Okay, right. Next question. Okay, obviously the question was the diagram below given for the mark distribution. On the same grid as the OGIF, sketch the histogram for the mark distribution of the grade. Assume 8 equal intervals. Obviously, we have 1, 2, 3, 4, 5, 6, 7, 8. Because the 8, this one is just the same as the bottom one, just that it's a bit untidy. Next, describe the skewness of the data. Right, so in B, you would look at the skewness of the data and see that it is more flatter towards the left. So since it's more flatter towards the left, we say the mark distribution. The mark distribution. Right, we say the mark distribution. Mark distribution is skewed. Is skewed to the left. Or is negatively skewed. Or it is negatively skewed. The mark distribution is skewed to the left or negatively skewed. State whether the statement is true or false. Explain. The median is closer to the upper quartile than the lower quartile. Is it true or false? Well, surely it is a true statement. Why is it a true statement? Data skewed to the left. If you want to say the data is skewed to the left, you can say they calculate the quartile values and make a decision. So in other words, you as a student, the learners can actually calculate the quartile values and make the decision. Right, so the quartile values, we're not going to waste a lot of time. They're sitting at Q1 equals 75, and then you have 85 for Q2, and then you have and 90 for the upper quartile Q3. Okay. let's proceed quickly. Right, section B, what statement can be deduced from all the statements with the following statements? A plus B plus C is 180 degrees, B plus E plus F is 180 degrees, A equals E, okay? What statement can be deduced from all those? Okay, what can we deduce? First things first, it's obvious, right? Because if these are both 180 degrees, you can say that angle A plus angle B plus angle C is 180, but it is equal to D plus E plus F. Okay, so these two guys are equal. Then you have A equals E. So, which means that wherever there is A and E, you can substitute by those. So, which means it is D. Wherever there is E, you can put A or vice versa. Like so, and this means that obviously at this point, A, it cancels A, and then the deduction that we can make out of this, B plus C. B plus C, that's what I want to say. I want to say B plus C is actually equal to D plus F. B plus C is equal to D plus F. That is the deduction that can be made. Next question, in the diagram below, two measure segments of circles are drawn with BD as a common tangent. Okay, so you have the measure segments, right, with BD a common chord, right? Both circles have equal diameters. Chord AB is parallel to chord CD. AB is parallel to CD. Prove that ABCD is a parallelogram. Okay, where do we start? What is the first step with this question? What is the first step with this particular question here? Right, first things first, we're able to see that angle B1 is actually equal to angle D2 because these are alternate angles like this. So we start by saying that angle B1 is equal to angle D2. These are alternate angles. Why are they alternate angles? They're alternate angles because AB is parallel to DC. What about C and angle A? Angle C and A are equal. Why? Angle subtended from equal chord.
Sir?
Yes, please.
So I was gonna say B2 is equal to D1 for alternate angles, and then say A and C are equal because of third angle in a triangle.
Okay, why do you think A and C are equal?
The third angle in a triangle, sir.
Yeah, I agree with you on that. I mean, okay. Okay, but obviously to have the third angle, you would need two angles first. What would the two angles be?
So B2 and D1 are equal
Good.
because of alternate
B2
angles.
and D1. I agree with you. So angle B2 is equal to angle D2. Okay, D2 is B1. Okay, we've already stated that. Right? Okay. But you're saying B2 and D1, right? Or
Yes, sir.
okay, you're saying this B for ban.
Yes, sir.
Okay, B for ban. Okay, so obviously we agree that these are equal to each other. So B1 is equal to D2, right? Okay, A equals C, but you would need two angles. So now to prove it's a parallelogram, you would need first two angles that are equal. Because you mentioned that A equals C like that angle, right? Did you say that?
Yes, sir.
All right, so because these two circles are congruent circles, because they have the same radius. Both circles have equal diameters. They have equal diameters. So these circles are like equal in area. They have equal diameters. So it means that this chord here, it subtends this angle A, the same chord subtends the angle C. So it's like angles in the same segment situation, these, but they've put them in different circles to just create. So in other words, obviously, it's like there's a chord. What is the chord? DB, the examiner wanted to be creative. In this chord, DB subtends angle A, its circumference. And then now there is another, it subtends angle A, but there's another chord like this that subtends angle C. Okay, so it's that kind of situation. But yeah, but it's just that they're subtended by the same. It's just that now this has been flipped around to be in a different circle now. The examiner tried to do that. So, but obviously you're on point. You're on point. C equals A because the angle subtended from equal chord of equal circle. Right. Are you on point to also say now we have the B1 and the A, so we can conclude about the third angle, D1 and B2. So we can say B2. The third angle now, because we're done with the A and the C, the B1 and this, want to prove these two triangles are sort of related to each other. And therefore, now we can say that B2 is equal to angle D1. Why? Because you can say angles in triangle, or you can say third angle. I agree. Next. Okay, the fact that now B2 is equal to D1, it means this angle is equal to that angle there. Means this angle is equal to that angle there. So if this angle is equal to this angle, it means this side is parallel to the side of the shape. In other words, we say this, but these angles are alternate angles. These angles are alternate angles. And because the alternate angles, these like already, this equals this in the alternate angles, that means BC is now parallel to AD. That means BC is parallel to AD. And ABCD is a parallelogram. It's a parallelogram. ABCD is a parallelogram. Okay, obviously we have to prove that ABCD is a parallelogram, and we've proven just exactly that. We given this information, and we went through the proof, and this is the proof. And we're done. Next question. You're on point, Marang. You were really right. Right. Obviously, looking at question 10 in the diagram below, the tangent at point A is parallel to CD. Okay, please, I'm going to engage you a little bit on this one to see how well you can manipulate it. I know it's pretty straightforward, but CD, A, and B lie on the circumference of the circle. CD, A, and B lie on the circumference of the circle. Okay, if it is given that angle B is 55 degrees, A1 is 18 degrees, then calculate the size of angle E2, giving reasons for your answer. I'm going to give you 1 minute. I'm going to be talking to someone just for 1 minute. I'm going to be talking to someone. And then when I come back after 1 minute, I'll actually get the answer from you. So yeah, 1 minute given to you to find E2. Over there. Hello, my dear. All right. These are right, my dear. All right, my dear. Okay, I'm back, madam.
I'm still busy, sir.
Okay, that's fine. All right, we're right back. Okay, I know that you're trying and you're going to be able to check your work against my work. So it's all right. It's all right. Okay, we're continuing.
So I got E is equal to 88 degrees.
Well done. Thank you. Excellent. Excellent. How many marks was that one? 6. Right. So yeah, we're going to do it very quickly. So first things first, we can see that angle C is equal to angle B because you're told that angle B is 55 degrees. Excellent. Well done there. Wrong, but these are angles in the same segment. So this is also 55 degrees. So that is the first thing we state, that angle C is equal to angle B 55 degrees. So angle C is equal to angle B, which is 55 degrees. Why is this the case? It is the Ten-Chord theorem. Ten-Chord theorem. So angle D2 is actually equal to 18 degrees because we know that A1 is 18 degrees here. So by the Ten-Chord theorem, if you have this, obviously you got that one right. I'm just doing it to make sure that we have some common understanding so that this angle is actually equal to 18 degrees. So which means that angle D2 is equal to 18 degrees. Why? Because of the the 55 degrees, the most accurate reason would be to say that angles in same segment, that would be the most accurate response to that part. So for the second part is the Ten-Chord theorem. So which means that D2 is 18 degrees. Right, once we find that D2 is 18 degrees, what is D1 plus D2? D1 plus D2 must be equal to 55 degrees. Right, because already you have that obviously this angle here. So D1 plus D2 is exactly 55 degrees because this equals that. So this is 55 degrees. This is a tangent, and therefore this angle equals that one there. So D1 and D2. Angle D1 plus angle D2 is equal to 55 degrees. Why is that the case? Because these are alternate angles. CD is actually, angle CD is actually parallel to the tangent. It's parallel to the tangent. It's parallel to the tangent. Okay, but D2 is 18 degrees. What is then angle D1? Angle D1 is 37 degrees. Because if you substitute D2 then subtract, you get 37 degrees. Okay, what is angle E2? Right, so angle E2 sits there. So angle E2, so we have already got angle D1, which is 37 degrees. So if 55 and 37 degrees, we need to get angle E2, so that E2 is 180. Angle E2 is 180 degrees minus 55 degrees minus, sorry, it's 180 minus 55 and 37 degrees. Why? Because of the angles in a triangle. Angles in a triangle. And therefore, we have that angle E2 is 88 degrees. So angle E2 is 88 degrees. All right, next thing, we're going to look more at other problems that are of great interest. Angle B. In the diagram below, circles with centers P and Q, P and O are drawn, tangents PD and PE to circle O cut the circle P and B and C respectively. A is a point on the major arc, BC, and DC cuts circle O at K, like that. So let's answer some questions that follow, like here. Okay, we saw this one, so I can give you like a split second because, yeah, I know that this one we did together last time. Like, we need to prove that angle O1, angle O1 plus twice A is actually equal to 180 degrees. Okay, I'm not going to waste a lot of time, but we know that at this point, the examiner said that tangents PD and PE. PD and PE are tangents to the circle with circle O. So this one is a radius, and that's a tangent, and that produces a 90-degree angle there. Radius and tangent, we have been told that PE and PD are tangents, so that you have the 180 degrees that is going to come as opposite angles, making this one a cyclic chord, the PDOE. And therefore, we start the proof by saying here, angle PDO is equal to 90 degrees. So angle PDO is 90 degrees because of the line from center. Line from center perpendicular to tangent. And then you have PEO. PEO is also 90 degrees, which is the line from center perpendicular to tangent. Right, so we have the 90-90, and then now we can have that angle P is equal to twice A. Okay, angle P is equal to twice A. So this one is the same as this kind of a theorem that is angle at center, and then it is like so. So angle P is equal to twice A. P is twice A. Why? Because the angle at center is equal to 2 times angle at circumference. Okay. And then now, if that is the case, what do we get? Right, so we can be able to see that angle O1 plus 2 angle A. In other words, angle O1 plus angle P can write that step. Angle O1 plus angle P is 180 degrees. Why is angle O1 plus P equals 180 degrees? Because this is already a cyclic quad, because the opposite angles are supplementary. So even the P in this is a cyclic quad, although it affects two cycles. So these are the opposite angles of cyclic quad. Okay, so that angle O1P is twice A equals 180 degrees. They say prove that O1 plus twice A is 180 degrees. And we've proven that exactly. Next question. Prove that C3 plus E1 is equal to 90 degrees plus A. C3 plus E1 is equal to 90 degrees plus A. Right, a couple of things are very important. You can start by looking at the angle O2. Can use a different way to the method we used last time. So the angle O2 is equal to what? The angle O2 is equal to 180 degrees plus 2A. Is 180 degrees plus 2A from the fact that this angle O1 plus O2 is 360 because the angles are on the point. So we can say that angle O1 plus O2 is equal to 360 degrees. Angles around a point. All right, and what do we know from the previous result? We know that O1 plus 2A is 180 degrees. So that angle O1 is the same as 180 degrees minus 2A. That is O1 from the previous results. And this is 360 degrees. You see, this is true because angle O1 is actually equal to 180 degrees minus 2A. And this has been proved in one above, which means that now we have to subtract everything. So what 360 minus 180, so you can be able to get angle O2, and O2 is going to be 180 degrees plus 2A. Right, so what is angle K2? Right, so we can see therefore that angle K2 is actually equal to 90 degrees plus A is equal to 90 degrees plus A. That is the angle K2. Right, because you have that the tangents PD and that intersect, and DC cuts the circles at that point. But it is clear therefore that angle K2 is going to be equal to 90 degrees plus A, because the angle at center is 2 times angle at circumference there. Because what do we know? Okay, a couple of things about the angle K2. The angle K2 is actually the same as what? Remember that if you look at this diagram here, this is already a cyclic quad. If this is a cyclic quad, there's a circle that passes through those points. Right, if there's a circle that passes through those points, we can be in a position to say the following. Let's start by saying angle K2 is equal to C3 plus E1. Angle K2 is equal to C3 plus E1. And this is the exterior grade 10 exterior angle. Exterior angle of triangle equals the sum of interior opposite angles. So that is what we get at this point. That is what we actually can be able to achieve at this point. But now, angle K2, like I was saying, this angle here, or you can use this angle there. Angle O2 is equal to 2 times K. O2 is 2 times K angle at center. 2 times K2. Angle O2 is 2 times K2. Angle at center equals to 2 times angle at circumference. So K2, O2 is equal to what here? O2 is 180 degrees plus 2A, and this is 2K2. This is true because the angle O2 is equal to 180 degrees plus 2A. Proved. Here. Above. It's been proved there. And so now you can divide through by 2. If you divide through by 2, that means that K2 is 180 degrees plus 2A, and you divide everything by 2. If you divide everything by 2, then it is exactly 90 degrees plus A is equals to angle K2. Okay, this angle here, you can call this one star and this one double star. So from star into double star, you have that K2 is equal to K2. If K2 equals K2, it means therefore that C3 plus E1 and K2 is 90 degrees plus A. K2 is 90 degrees plus A. So this is exactly C3 plus E1, which is 90 degrees plus A. So we're supposed to prove that C3 plus E1 is equal to 90 degrees plus A, and we've proven that. Okay, you can reduce the steps and try to include some relevant stuff there. Okay, this one I gave as a homework. Question 11. Okay, in the diagram below is a sketch of f of x and g of x. So we have f is this exactly 2 sine 2x plus 2, and the g is 2 cosine x plus 2. X is lies between 0 degrees and 360 degrees inclusive. Calculate the coordinates of point A. Now, this is easy. What's the answer? Okay, want to calculate the coordinates of A. How to find the coordinates of A? A is a point of intersection, so which means we need to equate the two functions. So equate the two functions, so we shall say 2 the sine of 2x plus 2 is equal to 2 cosine x plus 2. Which means 2 the sine of 2x. Right, so you can cancel the 2. 2 the sine of 2x minus 2 cosine x is 0. So what is the answer to this? can divide through by 2. Sine of 2x cosine x equals 0. 2 sine x cosine x minus cosine x equals 0. Cosine x, which is 2 sine x minus 1 equals 0. Cosine x equals 0, or the sine of x equals 1/2. Which means, therefore, that x, this one here is going to be the same. Arc cosine this is going to be plus or minus 90 degrees plus k times 360 degrees. The k is an element of the set of the integers. K is an element of the set of integers. Here, this one is going to be exactly x equals 30 degrees plus k times 360 degrees, k in z. And then here, okay, the sign is positive by the cast rule in 2 specific quadrants. It's positive in which one? In the first, but it's also positive in the second. So this one is going to be 180 minus 30. Minus 30 degrees plus k times 360 degrees times k, where k is in z, which means x is 150. Plus k times 360 degrees. Okay. You can remove one of the k's here. K is an element of z. So what is the answer? What is the answer? So that would mean a couple of things. When x is 30 degrees plus k times 360, what are the coordinates of A? All right, it is very clear, therefore, from this that the coordinates of A would be given by 150 together with minus the square root of 3 plus 2. Right, so at this point, in other words, you're going to look at what the value of x is. X is 150 degrees. So in other words, when you take one of the functions like f of x, what is f of x? Is the 2 sine 2x function. Okay, 2 sine 2x plus 2. F of 150 degrees is 2 the sine of 2 into 150. So 150. 2 the sine of 300 degrees. What is the sine of 300? Right, so the sine of 300 is the same as 360 minus 60. Right, and that would be minus the sine of 60. Okay, if you take these to up here, so if you have minus 2 the sine of 60 degrees plus 2, you remember the special triangles, 30 degrees, 60 degrees, 2, 1 is equal to 3. So right, so the sine of 60 is according to SOHCAHTOA. The sine is the opposite over the hypotenuse, which is the sine of 60 degrees is the opposite, square root of 3. Opposite 60 is square root of 3. The hypotenuse is 2 plus 2. And this is minus the square root of 3 plus 2. So that's why it is minus square root of 3 plus 2 there. Those are the coordinates of the point A. Next question. Okay, I gave you this one as a homework in the diagram below. You have an acute angle triangle ABC is drawn, right? And a line PQ is drawn. PQ is drawn where P lies on the line BC and Q lies on the line, Q is here on AC. The length of PQ is 14 units. Okay, they've shown 14 units. And the length of AB is 18 units. Right, angle A is 68 degrees. Here it is 68 degrees. You have angle C is 50 degrees. If the ratio of BP to PC is 2:3, determine the size of PQC. Right, PQC. I'm giving you a minute to check this one out and tell me what the size is here is required. The size of PQC. The size of PQC. The size of PQC. So we're interested in this angle here. Let me know when you're done. Okay, let me know please when you're done. Okay,
I'm almost done, sir.
all right. All right. All right, so I know you close. Okay. But obviously, one thing we need to realize is first things first, to find the angle, the size of PQC, we do not even know the length of BC. So one thing is to find the length of BC. By using the sine rule, we're going to say BC over the sine of 68 degrees. BC over the sine of 68 degrees is 18 over the sine of 50 degrees. So you have BC, which is 18, the sine of 68 degrees, divided by the sine of 50 degrees. Like so. Right, so we have been able to get BC. Okay, we're going to get the actual answer to this. But it's not the end yet, because we want to find now also we can find the length of PC. How do we find the length of PC? We've been given that the ratio of BP to PC is 2:3. If the ratio is 2:3, it means a couple of things. It means we can be able to find PC. And PC is going to be this one. So PC is going to be the same as the whole of BC. So to get PC, you can get the whole of BC and you multiply it by 3:5. So to get now PC, we can take the whole of BC and say BC times 3:5. Right, we are in a position now to continue with this. Then we go to the final step. After this, the final step now is to now just work in this triangle here. In that triangle there. To find the angle they want, PQC. So in that triangle, so effectively here, we actually worked in triangle ABC. Now we're going to work in triangle PQC. So what is the answer? The sine of PQC. Right, the sine of PQC divided by PC. So the sine of PQC divided by PC is equal to the sine of 50 degrees divided by 14. We done? We have all the equations we need. So we want the sine, we want PQC, so we're going to cross multiply here. PQC. So this is going to be PC times. Okay, it's going to be PC times the sine of 50 degrees over 14. Which means the sine of PQC is equal to, what is PC?
So can I give you my answer in the meantime?
Yes, please.
So I got Q is equal to 45.6 degrees.
Well done. That's the correct answer. You've got PQC equals 45, right?
Yes, sir.
45.6. Approximately 0.66 degrees. So yeah, that's the correct answer. So yeah, it is the correct answer. So obviously PC is this. So PC, there are many ways of doing the question anyway. So PC, now you can put the BC times 3/5 times the sine of 50 degrees over 14. What is BC? BC is all this. So which means here we can continue and write, what is BC? it is 18 the sine of 68 degrees divided by the sine of 50 degrees multiplied by 3 out of 5 multiplied by the sine of 50 degrees divided by 14. So which means that the sine of PQC is exactly the same as, okay, so you multiply everything here, you get 54. The sine of 68 degrees divided by 70. Okay, this is when you move this to here. Right, and when you get to that point, you have PQC, which is arc sine of 54, 68 degrees divided by 70, which is, as you said, if you use a calculator, arc sine that is 45.66 degrees, approximately, and that is the answer. Okay, so you're really on point in doing this question. Below we have the diagram there, and you have to find if the ratio of BP to PC is 2:3, BP to PC is 2:3, determine the size of PQC. PQC angle PQC, you got 45.6 approximately. So we found that PQC is 45.66 degrees approximately. So we have that. Let's to get the proof of this. Right. How do you prove this? What is the first step? Which side would you take? The left or the right? Must take one, or you can take both. You can take both sides. So which side do you take of these? Prove that that is the case. Either you take the left to produce the right, or you take the right to produce the left. Let me give you like 2 minutes. Let me know when you're done, please. Let me know when you're done. Okay. You're done.
I'm almost done, sir.
All right. All right, I know you're done. Pretty much, you close. Left hand side. You just take the left, it's complicated. So we have the cosine of A minus 45 degrees divided by the cosine of A plus 45 degrees. Right, there are two identities we use all the time. The cosine of alpha minus beta is the cosine of alpha cosine beta plus the sine of alpha, the sine of beta. Cosine of alpha plus beta is cosine alpha cosine beta. If it's plus, it becomes a minus sine alpha sine beta. So which means that this one is going to be actually cosine of A cosine 45 degrees plus the sine of A, the sine of 45 degrees. Just used the first one with cosine alpha minus beta. The second one with the plus, which is cosine A cosine 45 degrees. If it's plus, it becomes minus the sine of A, the sine of 45 degrees. Cosine A, this is 1 over the square root of 2 plus the sine of 1 over the square root of 2 divided by cosine A 1 over the square root of 2 minus the sine of A of 1 over the square root of 2. So you have 1 over the square root of 2, which is cosine A plus sine A, which is divided by 1 over the square root of 2, which is cosine A minus sine A, cosine A plus sine A, cosine A minus sine A, like so. Effectively, what this? Yes, my dear. Is it? Oh, all right, my dear. All right. Just a minute. I'm coming back now. Maran. Okay, she's my dear. All right, my dear. All right, we continue, Maran. So as you get to that point, effectively, the left-hand side is the cosine of that. So it is cosine of A plus sine A divided by cosine of A minus sine A multiplied by the conjugation plus sine A, cosine A plus sine A. And so if you multiply, the bottom is a difference of 2 squares, because if you have A minus A squared minus B squared is always A minus B into A plus B from grade 10. This is called the difference of 2 squares. So which means in the bottom now is cosine squared minus sine squared. The top is going to become cosine A times cosine A, which is cosine squared A, which is cosine A times sine A is cosine A sine A plus, yes, please.
So how do you know when to multiply by the conjugate?
Okay, we need to rationalize the denominator. So we change the sign of the denominator because the denominator has a minus here. So we multiply by the expression that has a plus sign in the middle, because this one has a minus. So we always rationalize, we use the word, we rationalize the denominator. Right, we rationalize the denominator. Right, so when you rationalize the denominator, we change the sign of the minus to become a plus. And we get to this point. But now then this brings a difference of two squares. If you multiply a minus b with a plus b, you just multiply cosine a, and sine a, and get the squares like this and not waste time. But you can multiply these times these times that, these times these, and so on. But now next you multiply this by that. This is exactly the same. It's cosine a plus sine a twice. So it is cosine a, which is squared. Then you multiply this with that, which is sine a cosine a plus sine a cosine a. It is 2 sine a cosine a. Then your sine a times sine a, which is actually sine squared a. So right in the end, we have cosine squared plus sine squared is 1 plus 2 sine a cosine a is the sine of 2a divided by cosine squared a minus sine squared a is the same as cosine 2a, and this is actually the right-hand side of the expression. Because the right-hand side of the expression is 1 plus sine 2a over cosine 2a, 1 plus sine 2a over cosine 2a, 1 plus sine 2a over cosine 2a, 1 plus sine 2a over cosine 2a. And we have proven that. Next. And as I indicated, what we call this expression multiplied by is called the conjugate. What is the conjugate? So in other words, if a minus b is given, then its conjugate is a plus b. So similarly, if you're given a plus b, if this is given, its conjugate is, the conjugate of a plus b becomes a minus b. We just look at the denominator in which to dissolve the denominator. Normally, it works to dissolve the denominator. In this case, we multiplied by the plus, and suddenly the long thing that was cosine a minus sine a just became cosine 2a because of this clever trick. Obviously, we're dividing this by itself, meaning we're multiplying by a 1. Next question. Okay, in the diagram below, P and Q are centers of circles having equations: x minus 7 all squared plus y plus 2 all squared equals 49, and x squared plus y squared plus 10x minus 6y equals 30. Determine the radius of the circle having center Q. What do you think the answer is? Giving you like a split second.
So I forgot how to do this.
Okay, that's fine. So if you look at the fact that now you have been given these, so in the diagram below, P and Q are centers of circles having equations these. So they did not say which one is which. They just said these two circles have those equations. So one equation is for a given circle. Right, so which one is which? They played around with this. So you just need to look at the two centers. So now determine the radius of the circle having center Q. Center Q has two things, has x negative. X is negative as the coordinate, but y here, y is positive. So can it be this one? Obviously, if you look at the coordinates, it's going to be 7 minus 2. So it's not this one. Okay, because if it's 7 minus 2, then x is positive, x must be negative. So it has to be then this equation. So we're going to take that one and manipulate it. It is x squared plus y squared. We write it down here. X squared plus y squared plus 10x plus 10x minus 6y equals 30. Okay, we need to complete the square to find the radius. How do we complete the square? We group the x's and the y's together. So that is actually exactly x squared plus 10x y squared minus 6y is equal to 30. We actually therefore have x squared plus 10x, half the coefficient of x, plus, then you have y squared minus 6y. Then you add half the coefficient of y. This is called completing the square. Now, then we have 30 on the right-hand side of the equation. Obviously, 30 was there, but we have half of 10. What is half of 10? Half of 10 is 5. If you square that, it becomes 25. Half of minus 6 is minus 3. You square that, you get a 9. Okay, this one is easy to factorize. So you look at the half of 10, which is 5, you just put because half of 10 is plus 5, put a plus here. And then here, half of minus 6, because the minus 6 equation of y is minus 3, you square it. If you add everything here, this one is going to be 34 and it's going to be 64. What is the length of the radius? The radius, right, so it means the radius is r equals the square root of 64. What is the square root of 64? It is actually 8 units. The square root of 64 is what? Is 8 units. Next, so we wanted to find the radius of the circular leafing center Q. Yeah. Is it the radius of the center Q, this one? Obviously, yes, because if you find the coordinates of the center, you'd have that the coordinates are -5 and 3. And just right here, part of the answer is not needed, but the coordinates of the center would be -5 together with 3. X negative and y positive. So you can see x negative, y positive. Those will be the coordinates of the point Q. All right, calculate the length of PQ. Calculate the length of PQ. Right, so we can find easily the length of PQ given some 3 marks. Right, to find the length of PQ, we have this, Q is this one. We have already seen -5 and 3, and we have the coordinates of P, which are what? P is the other one, with the coordinate 7 and -2. 7 and -2. So P has the coordinates 7 and -2. Want to find the length. So we can easily find the PQ using the distance formula, which is x2 minus x1 squared, y2 minus y1 squared. So x1, y1, x2, y2. What is x2, which is 7 minus x1 is -5. You square that, -2 minus so you have the square root of 169, which is 13 units. So the length of PQ is actually 13 units. Next question. Show that the equation of PQ is 5x plus 12y equals 11. Right, so we can easily do that one. The coordinates of the point Q, they are 5 -5 and +3. Coordinates of Q are -5 and +3. The coordinates of P are 7 together with minus 2. Let's find the equation of the line PQ. First, to find the equation of a line, we need to find the gradient of the line PQ, and the gradient of the line is change in y, change in x, which is y2 minus y1 over x2 minus x1. Okay, PQ, x1, y1, x2, y2. So y2 is 3 minus y1 is minus 2. X2 is minus 5, x1 is 7, which is 5 here over minus 12. Just like so. And therefore, you have used the formula y minus y1 is m into x minus x1. So obviously use any of the points. This line passes actually through both points, P and Q, which is 7 to minus 2. So which means it is x1, y1, which is y minus y1 is minus 2, which is m, which is minus 5 out of 12. It is x minus 7. So y is the same as what? Right, so it is exactly the same as the following, as minus 5 out of 12x plus 35 out of 12 plus 2 minus 2. X plus, so this is 24. $11. This is going to be exactly 11 out of 12. Like this. At this point, you can just multiply through by the lowest common denominator, 12. So this implies that you have 12y is minus 5x plus 11. So which means that you have 5x plus 12y is equal to 11. You have 5x plus 12y is equal to 11. 5x plus 12y is equal to 11. 5x plus 12y is equal to 11. It has exactly been written. In fact, oh, there it is. 5x plus 12y equals 11 is what the gift was, and that is what we got in this question. Next question. Determine the coordinates of A. 5 marks. Determine the coordinates of A. Right, so how do we find the coordinates of A? There are two ways, obviously, to find the coordinates of A. And it is a point of intersection of the line PQ and the smaller circle. The smaller circle has the equation x minus 7 squared plus y plus 2. So x minus 7 squared x minus 7 squared y plus 2 yes, y plus 2 all squared equals 49. So you have y plus 2 all squared equals 49. And we have these two that intersect. Right, these two intersect, and then you need to solve them simultaneously. So at this point, so you divide by 12, which is minus 5 out of 12, x plus 11 out of 12. So you get this. So if you call this one equation 1 and you call this one equation 2, substitute 2 into 1. Wherever there is a y, you put this, or the other way around. Simultaneously, you can just say you make x the subject of the equation, which means you're going to have x is equal to minus 12y out of 5 plus 11 out of 5. So which means, therefore, in the place of x, you put minus 12y out of 5 in the place of x. Plus 11 out of 5 minus 7 squared. And then you have y plus 2 squared equals 49. So if you manipulate everything here, you then have, this becomes 169y squared plus 676y minus 549 is equal to 0. So 169y squared plus 676y minus 549 equals 0. So now we want to look at these very carefully and to be able to solve this particular question. We need to get the factors of this expression, and it's easy to factorize for us. It's easy to factorize this. And if you factorize this, what do we get? It is 169 y squared plus 67 676 y minus 549 equals 0. So, right, when we're getting here, right, the actual factors of these would be (13x) and therefore which y. Right, which means therefore at this point we have y is 9 out of 13, or y is minus 61 out of 13. So you substitute into the this equation, the y, and you get what? You'll be able to see that if you substitute the one that's going to work, because this one is saying y is negative. He's saying y is negative. Let's look at the position of A. A is on the positive side of y, so y is positive here. It's in the first quadrant where x and y, so y is positive and also x is positive. So which means, therefore, that the coordinates of A would be a point where the y is 9 over, so this one is invalid because it's a negative y. A is in the first quadrant and both x and y are positive there. So we shall take y equals 9 out of 13. If you substitute y, you get x, and x is going to be 7 out of 9. 7 out of 13, excuse. Put the y there, and you're going to get 7 out of 13. Obviously, you can't waste a lot of time on that one. It's easy to just substitute into that equation there. Next question. Determine the equation of chord CD for 3 marks. Where is CD now? Let's check in the diagram. Where is chord CD? This one. Okay, so let's find the equation of chord CD. Right, so to find the equation of chord CD, there are a couple of things that we need to do. So chord CD is at a point where the circles intersect. Circles intersect along chord CD. Okay, because they intersect, what does it mean? You have the 2 circles, and what are the 2 circles? So you have the first one, which is x minus 7 all squared, y plus 2 all squared equals 49. X minus 7 all squared y plus 2 all squared equals 49. And the other one is x squared plus y squared plus 10x minus 6y plus 10x minus 6y these plus 10x minus 6y equals 30. Equals 30. Equals 30 exactly. Equals 30. So if you equate this, this is x minus that squared y plus 2 squared minus 49 equals 0, together with x squared plus y squared plus 10x minus 6y minus 30 equals 0. Okay, these two equations both are equal to 0, which means x minus that squared plus y plus 2 minus 49 is equal to x squared plus y squared 10x minus 6y minus 30 equals 0. Simplifying everything, if you square this one here, it is x squared. X times minus 7 times 2 is minus 14x plus 49 plus y squared plus 4y plus 4 minus 49 is equal to x squared plus y squared plus 10x minus 6y minus 30. Okay. You simplify everything, the x squared cancel, the y squared cancels, and you have exactly 10y minus 24. X is equal to minus 34. Right. So the equation can also be written as y is equal to 12 out of 5, 12x out of 5 minus 17 out of 5. That is the equation of the chord. So to get the equation of the chord, because the two circles intersect, you just make the, because you have one circle here, the other circle there, there's a chord just that lies like so. The equation of this chord would be obtained by exactly this, which is the equation of the chord where the two circles intersect. Next question. Prove that CD is perpendicular to PQ. Prove that CD is perpendicular to PQ. Let's look at that. What is the gradient of PQ? What is the gradient of PQ? We have the equation of PQ. Right. So the equation of PQ is exactly this one, which is y equals minus 5x over 12 plus 11 over 12. Minus 5x over 12 plus 11 over 12. X over 12 plus 11 over 12. And the equation of this one is for PQ. What is the equation of CD? Is this one. So, which means therefore we'll take the gradient of PQ times the gradient of CD. The gradient of PQ is minus 5 out of 12, of CD is 12 out of 5. And therefore, the result is minus 1. Because the product of the gradients now, the product is minus 1. Hence, we infer that CD is perpendicular to PQ. CD is perpendicular to PQ. Like that. Okay, here's question 13. A farmer has come up with an accurate way to measure the volume of water in his water tank. You place the triangular wedge with an angle A equals 30 degrees. Okay, remember, this farmer has come up with an accurate way to measure the volume of water in his water tank. Okay, sometimes he's interested in knowing how much water is in the tank. So you place the triangular wedge and with angle A equals 30 degrees in the water tank until point A is touching the bottom of the tank. Until point A is touching the bottom of the tank. Right, you pull the triangular wedge out of the tank and look for the watermark made on the wedge. This is indicated in step 2 as line BC. There it is, line BC. Okay, step 2. So you have the water mark is there. You put the wedge inside and are able to check the level of the water there. Okay, the watermark to say to what extent is this wedge wet? So you look for the watermark where it is wet. Right, so if the farmer's water tank has a radius of 3 meters, We have seen 3 meters, and he measures AB to be 100 centimeters. Okay, obviously we've seen that it has a radius of 3 meters. And he measures AB to be 100 centimeters. AB to be 100 centimeters and AC to be 150 centimeters. AB is 100 and this one is 150. Determine the volume of water in the water tank. Only round off at the end of your calculation. Use volume equals pi r squared h. Use volume equals pi r squared h. The end of the exam. Because at the end of the exam, I'm going to give you this question to just show me what you can do here. Here's the information. Everything is here in the story. So we start here. Question 13 was the last question in this exam. So you have the word, just an application question. They just want to see is just creativity from the examiner, something different. And now you have the words there. So we want to know the level of water in the water tank. Want to know the level of the volume of water in the water tank. It is up to BC. The question is how much water is in this tank? How much water is in this tank? Let me know, please, when you're done. Let me know, please, when you're done. If you need more information, I can move. I can show like the bottom figure. Want to know the volume of water in this water tank. How much water is here with this method? Because you can see the water is reaching BC. Because the water mark is at BC. But how much water is in the tank altogether?
I'm really not sure where to start.
All right, that's fine. Okay, last question in the exam. It was there to say goodbye, goodbye, grade 12s. And right, so obviously there's only one thing. You can see what we need to do here. We want to determine the volume of water in the water tank. Like this formula says, V equals pi r squared h. That is the formula. So the radius is already there, and it is 3. The radius is already there, it is 3 meters. There is the radius is 3 meters. So radius is 3 meters. The only thing missing is the height. So if you find the height, then we shall be able to find the volume of the thing, because we're supposed to use this formula. What is the height? Right, the height will be obtained from these things here. How do we get the height from this watermark? And the figure here to say if the water is up to this point, what is the height here? Right, so we have a triangle, this triangle here. And this triangle is going to give us, we can use it to find the length of BC. So if we have 10, like 100 centimeters, 150 centimeters, and then we just need to find BC. Right, so something like this. You have like 100 here, 150, 30. This is BC. A. So you have this. So you can use the law of cosines, or what we call the cosine rule. Right, so if this triangle is there, then this is like small a, and then this one is small b, and this one is small c, opposite vertex c. So we want to find BC. So it's like a squared is equal to b squared plus c squared minus twice BC cosine A. Okay, this one you divide by 100. Divide by 100, the decimal point is going to shift. It's going to be 1,5 meters. 100 divided by, if you divide it by 100, it's going to be like 1 meter. Like so. So, which means that the B is going to be 1,5 squared plus the C is 1 squared, 1.5 times 1 cosine 30 degrees, like this. So which means that now we shall be able to get the A, which is the square root of everything. A is the square root of 1,5 squared, 1 squared minus 2 into 1.5, 1 into cosine 30 degrees. And this is 0,807, and these are meters. So next we want to find the area of the triangle. So the area of triangle ABC. Right, by using the area formula, the area of this triangle is half BC, the sine of A. Which is half B, which is 1.5. C is 1 meter times the sine of 30 degrees. Times 1.5 times this, which is 1/2. So this is 0.375 square meters. Now, after this, Then we want to find the height of that is required, which means if this is the case, here is the wedge. The area of triangle ABC is half base times the height. We've already got the area of the triangle, 0.375, which is half BC times the height, which is what is wanted. So if you manipulate everything out of this, you multiply it through by the 2, and you divide, because this is A, but it's also BC, this one. So yeah, H is going to be 2 into 0.375 divided by BC, which is 0.807. BC is this one. And H 0.92, 0.92, then you get 888. Then you get 692.34. Right, so that is going to give you the height of this triangle. Once you get the height of this triangle, then we can find the volume of water tank. End of the exam. Volume of the water tank. Determine the volume of water in the water tank. So the volume of water in the water tank is pi r squared h, which is 3 squared times the height, which is 0.92888693, then 4. You have this one, which is exactly 26,26 square, rather cubic meters, because it's volume. Cubic units because it's volume, cubic meters there. So obviously the answer we're actually saying is 26,26 cubic meters. So that is the volume of the water tank there. So right, and that is what the examiner wanted in this last question in the exam. So you have a question 13 IEB exam paper 2015, paper 2, November. Right, you put the wedge there and realize it makes an angle of 30 degrees, but this is 100 centimeters or 150. How much is the, because obviously the examiner wanted to just ask you to find the level of the actual height of this. But most importantly, you need to realize that in this question, the BC was like top. So it was like full. It was like full to capacity. So the water in the tank was full. All right, if the tank was full, then you get 26,26 cubic meters. I must thank you for joining us, Maran. I'm going to see you again later on today. Okay, so that we can do more. I'm going to bring more things. So I'm going to check with you. I'm going to bring another question on the thing. On what? I'm going to bring another question on the
So I think
Yes?
more questions on geometry are fine.
Or more questions on geometry?
Yes, sir.
Okay, that's fine. I'll bring more questions on geometry, but yeah, I'll try to get a lot of questions on geometry. But also potentially maybe some questions on scatter plots, in particular where the regression line must be drawn. I'll try to get those questions as well. Okay. Otherwise, thanks for now, Marang. I'm going to send you the time, but I'll be seeing your brother now at 4. Okay. Thanks, Marang. Goodbye.
Goodbye, sir.
Goodbye, Marang.